Hi, this video will cover section 1.3, evaluating functions using function notation. And this video is for the class Math 0305 with the co-requisite of Math 1324. First, we're going to start by fill in the blank. So we have here our first statement, and it says the notation blank denotes that the variable y is a function of x. And so in this case, we're going to stop using just y as our dependent variable, and we're going to replace it with f of x. In this case, we will always know what x value we're referring to. And this is very useful when we need to find, we're given the input or the x value, and we have to find the y value, the output. We often use letters such as f, g, and h to name functions, and we read them as f of x. I don't want you to think that the two things that you see here are multiplying each other just because you have a parenthesis. It is function notation, and it is f of x. So for example, if I had something like f of 3, parenthesis 3, I will read it as f of 3. And this will mean if x is equal to 3, what is our y value equal to? All right, so whenever we write, let's go to the next statement. Whenever we write function notation, we assume that the variable x is an independent variable, and both y and f of x are the dependent variables. And let's put here function notation, which is the f of x. Okay, so let's move on to our first example here, and we do have functions on the left side. The first column is the equation of each function, as you can see. Then the column in the middle is what we're calling the skeleton. And this is just going to help us prepare for what comes next on the third column, which will be to evaluate. And when we see evaluate, that means find a numerical value. So if you look at this example here, we have the function is 2x minus 3. That is a linear function. The skeleton, we're simply just taking the x, removing the x's from both the function notation and the equation. And you could see they're just replaced with parentheses, as you can see here. That's the skeleton. Now for the function value, we go and we actually use the value given to us, in this case -2, and we're going to go ahead and substitute it here. So then we'll have 2 times -2, that would be -4. And don't forget, we still have a -3 there. And so just to answer this question, it will be -7. So what this means is that f of -2 is equal to -7. In other words, what we're saying here is that if our x is -2, then our y will equal to -7. That's what we're finding, the output. So let's go ahead and work with the next function. The next one that you guys see here is a quadratic, and we're calling it g of x, and that's why the skeleton has g for instead of f, and that's perfectly fine. As you see, we have an x here that needs to be squared, so we have the parentheses. And we have another x here, and we still do have those parentheses there. Now let's go ahead and carry out the operation. So we're going to find g of 5. In other words, the question is, if x is equal to 5, what is my y equal to? That is what we're looking for. So we substitute following the skeleton. So we need parentheses, 5, close parentheses, then square, -4, open parentheses, 5. And then we need a plus 4. Now, following order of operations, first we need to do the square. 5 squared, or 5 times 5, that's 25. Then we have negative 4 times 5, which is negative 20. And then we have a plus 4. So here, 25 minus 20, that will be 15. And then plus 4, so that will give me 19. So g of 5 is equal to 19. In other words, when x equals 5, the y value is 19. Now let's move on to our next function. It's also a quadratic. So first we're going to focus on creating the skeleton. So f parentheses equal, we have a 3 for the coefficient right there. Then we come up across an x, so I'm going to put a parentheses there, and we need to square it. So I'm going to make sure to have that outside my parentheses. Then minus, we do have another x there, so we're going to put a parentheses. And then let's not forget about the plus 5 of the constant term right there. Now to find f of negative 3 using the skeleton, we would, actually I made a mistake there. So we're going to use 3 parentheses negative 3 in place of the x, this x right here that we put in the skeleton. Then we need a square, and then we need a negative, then we need a negative 3, and then we still need a positive 5. Following order of operations. So it follows that we must do the square here. Keep in mind negative 3 times negative 3 is going to give us positive 9. And then from here we have this double negative, so that will be plus 3. And then we have a plus 5. Now let's go ahead and multiply here. 3 times 9 is 27. So 27 plus 3 plus 5. And that will give us 35. And so that is our answer for that question. So remember, if x is negative 3, I'm sorry, the y value will be 35. That's what we found here. So let's move on to our next two for this page. And sometimes it's okay to substitute letters like we have here. It's not only reserved to substituting numbers. So I'm going to write down the skeleton for this first. So it's 3 parentheses and then plus 7. And so what we're going to do now is just replace this a, the variable, in the skeleton. And so it will look like this. 3 parentheses a, close parentheses, plus 7. All we could do here is just distribute 3 times a, and that will just give us 3a plus 7. And that is the answer. Your answer could be an algebraic expression. It does not have to be always a number. Now the next one, x plus h, and this will be helpful once you get to do some problems of the difference quotient. So in this case, I'm going to do the skeleton. And now what we're going to do is substitute everywhere where we put a parentheses is going to be substituted with x plus h. Now here we're going to have a square, and then following the same skeleton we need another one here, parentheses, and then x plus h. After that we still need to account for that positive 9 that we have there still. Okay, so here, this one here, it's same as saying x plus h times x plus h. And so we need to also distribute this 3. So let's do that. Negative 3 times x is negative 3x. Then negative 3 times h, it will be negative 3h. And we still have this plus 9. Now what I'm going to do here is distribute this two binomials. So I will be, maybe in a previous class, your teacher referred to it as FOIL. So I'm going to multiply x times x, and that will give me x squared, then x times h, xh, then h times x, hx, and then lastly h times h, which will be h squared, minus 3x minus 3h, and then plus 9. From here, the only like terms are those two. So we'll have x squared plus 2xh plus h squared minus 3x minus 3h plus 9. And that long answer is actually the answer to our question. And this concludes the video. This is just section 1.3, part 1. There are other 2 pages that we need to cover. So thank you for watching.